Hi everyone, this video is on exercise 9J question 11. The volume of a cube is decreasing at a constant rate of 4.5 centimeters cube per second. Find A, the rate at which the length of one side of the cube is decreasing when the volume is 100 centimeters cube. Okay, so this question has some similarities to question number 10. First of all, we need to write the differential equation for the rate of change of the volume of the cube, because it's saying that the volume is decreasing at a rate of 4.5 centimeters cube per second, which is basically saying that dv dt is equal to minus 4.5. So the reason for this minus is simply because it's decreasing and the volume is decreasing, so that's why we have a minus. So note that part A is asking for the rate at which the length of one side of the cube is decreasing when the volume is 100 centimeters cube. So this question is essentially about the length, and it's very important because the initial differential equation that we have written is for the rate of change of the volume. So a quick reminder that the volume of a cube, since it's a cube, is equal to, let's say the length of the cube is L, so then the volume is going to be L cubed, right? So this is the volume of the cube. And so since the volume of the cube is L cubed, now we can easily find dv L, right? Because it's going to be useful for part A. As you can see, part A is about the rate of change of the length. So, and also the question is given us the volume, so you can see that there should be a connection between the volume and length. So dv L is equal to 3L squared. Okay, now part A is all about the rate of change of the length, right? So what that means for us is that we first need to write the LDT, because again we want to find the rate of change of the volume, sorry, the length. Now it's the chain rule again, so we need to choose two other rates such that their multiplication gives us the rate on the left hand side. So on numerator I have the L, so I need to find the L on the right hand side. I have to have dl on the numerator of one of the fractions on the right hand side. So I have dl now. So one possible thing is dl by dv, because we already have the dv by dl, so we can easily find dl by dv, right? Because that's just the reciprocal of that. And this times by dv dt, because remember we already have dv dt, it's here, so that's minus 4.5. So we just need to find the LDV before we can find the LDT, and that's easy because the LDV is just a reciprocal of dVdl, which is 1 over 3L squared. Right now it's all about the substitution. So the LDT is equal to, the LDV is what we just found, 1 over 3L squared times minus 4.5. So now we have sorry, this is also multiplication, so times minus 4.5. And what happens here is that we are going to get, okay, so before I solve this, I need to remind you that we haven't found the value of L yet, and that's going to be very useful, because for the LDT we are going to have minus 4.5 over 3L squared, but we don't know the value of L. So we can easily work out the value of L, because remember that in this case the volume is 100 centimeters cubed, and when the volume is 100 centimeters cubed, we can solve a simple equation that 100 is equal to L cubed, which means L is equal to the cube root of 100. Now we are going to use this here, because we need to substitute that here. So we'll have minus 4.5 over 3 times L squared. So L is the cube root of 100, but the squared. And this is equal to minus 0.3 0.07 to basically two decimal places, and the units are centimeter per second. So this is the rate at which the length of the cube decreases. But just be careful, because this negative basically is telling us that it's decreasing. But if the question is saying that what's the rate at which this decreases, you just need to say it's 0.07, because they're already saying decrease, so they are taking the negative of this into account. So you just say 0.07. Just like how it's being said here. It's saying that the volume of a cube is decreasing at a constant rate of 4.5 centimeters cube. It's not saying at a constant rate of minus 4.5 centimeters cube. But for the differential equation, we need to write that negative to show the decrease. Okay, this is the answer to part A. Now for part B, we need to find the volume of the cube when the length of one side is decreasing at a rate of 2 millimeters per second. So this part is basically saying that the volume of the cube when the length of one side is decreasing at a rate of 2 millimeters per second, we first need to find the length of the cube, because it's basically giving us that when the length of one side is decreasing at a rate of 2 millimeters per second. So first of all, remember that 2 millimeters is equal to 0.2 centimeters. And then the information from the question is giving us the LDT. The LDT, according to question, is minus 0.2, because this is the amount that the length is decreasing. So the length of the one side is decreasing at the rate of 2 millimeters per second. Okay, this is what the question has given us. And we first need to find the length from this equation. And then once we have the length, we can easily find the volume of the cube, because volume is equal to length cube. So for the LDT, we need to just use what we already found in the previous part, because the LDT is equal to minus 4.5 over 3r squared. So we know the LDT is minus 4.5 over 3r squared is equal to minus 0.2. So it's a good sign, because we have two negatives and the negatives are going to cancel out, and because the answer is going to be a length, and length is always positive. So these are, some little things that can help you at times. In case you're getting a negative length, you can see that something is wrong, and you can then go back and check your solution. So we just need to solve this, basically. We are going to have 4.5 over 0.2 is equal to 3l squared. And then after solving this equation, so if we simplify this first, L squared is going to be equal to 7.5, and the value of it is equal to square root of 7.5. So the length is root 7.5 centimeters. And since the question is asking, okay, what's the volume? So V is equal to length cubed. So it's going to be 7.5 root 7.5 cube centimeters cube. So this is the volume, and the question, is not really asking us to give this to a specific decimal values. So therefore, this is the final answer to this question. Okay, thank you for watching.